So, Jess was talking about onboarding a billion people. I can tell you none of the blockchains today can actually solve that problem. You're not going to be able to onboard a billion people today. So we're going to talk about economies of scale a little bit, and this is how we're going to onboard the 7 billion people in the world, and AI and IoT at the same time. So Syscoin is one of the older projects, right? It's a project back from 2014. You can say we're OG. We were peak valuation of over $1 billion. We're ID 16 on CoinMarketCap. And many of the people probably here have heard of it, but they don't know what it's all about. We've been kind of, banging head on the keyboard trying to figure out how to scale this stuff. Ethereum, Bitcoin, and all these other blockchains which are monolithic. We're trying to figure out how we can think about IoT, smart cities, AI, and all the different people in the world that need to be onboarded to preserve sovereign financial value. So what we are today is a dual chain architecture. And basically, we're thinking about ways to create things modular, right? You can't put everything on one layer. If you put everything on one layer, you'll hit a bottleneck at some point. Some of the blockchains are already hitting that. We're Byzantine fault tolerance, actual faults where blocks aren't forming anymore, which is kind of the death signal of any of the distributed systems is when a system stops performing and it has a fault. You gotta prevent that. In order to prevent that, you have to build a modular design, right? We're talking about roll-ups, and also in our case, we're splitting up our tech stack from UTXO, which is Bitcoin-like, and EVM, which is Ethereum-like. And our security model is tied on the UTXO back into Bitcoin directly. So we'll talk a little bit about what that means. But a modular design in our context, and also Ethereum means we are a roll-up driven roadmap. We are thinking about ZK rollups. We're thinking about optimistic rollups. We have to push users off of the base layers, right? The only way you're going to get economies of scale is if you reduce the fees. The more users jump on, the cheaper it has to get. This means there's going to be multiple rollups. There's not going to be just one. There's going to be multiple. And so Rolex, we just announced, is entering testnet, and soon it'll be mainnet. But coupled with that, once you get into a rollup-centric roadmap, you have a specific problem, right? Either you're doing a sidechain, in a sidechain, what Plasma was trying to do with Ethereum and Bitcoin sidechains, you have a specific problem where how do you know that you'll be able to go back to the base layer? If it's not inheriting the layer 1 security, then what's the point, right? There's censorship attack issues there. So what you have to do is post some minimal amount of data back to the base chain, back to Ethereum, and call data. And what's happening now with Optimism, Arbitrum, and ZK Sync and Starknet is they're putting the data on the layer, and all of the fees are going up because they're putting the data on that base layer. So, and we've been researching this for a while, and we found, why don't we break that problem down a little bit and solve that in a more unique way without putting it on the blockchain? We're using the blockchain as a repudiation mechanism to secure the data, but at the same time, provide security and decentralization and reducing the fees. So every node in the future doesn't ever have to sync up with the data, but the data has been secured by the blockchain itself. And this way, with data availability, if anyone in the tech circles will tell you, is a core critical problem in a modular blockchain. If you have the base layer securing that, but you don't have to have the ability to resync all this data every single time, we're talking terabytes and terabytes, then you end up creating economies of scale. Our security layer is unique, right? As ETH is merging over to proof of stake, and there's some fallbacks. There's more game theoretical implications there. There might be new attack vectors. We don't know. Bitcoin, however, has been around a long time. It has Lindy effects. It has security. It has decentralization. That's the gold standard, right? And actually, if you want to prevent spam, you want to prevent denial of service, you can easily check that there's been work done and prevent certain actions from happening. And proof of stake, you don't have that. So what I like to say is proof of stake, it doesn't prevent irrationality, but proof of work prevents irrationality, irrational behavior. Where if I have enough money to throw around, I can screw around with that proof of stake layer, but you won't be able to get anywhere on a proof of work layer. And when you talk about decentralization, there's a certain metric we like to throw around. It's called Nakamoto coefficient. How many aspects of your blockchain are separate in a way where if one is confiscated, it's still secure. The higher the number of the coefficient, the more decentralized the system. Our master layer are essentially just paid. They're just paid to run full nodes. Ethereum probably has like a half a dozen full archive nodes right now, right? But if you had these incentivized nodes to run full long term, which Vitalik would like to say, a dev, basically part of the block subsidies being paid to for devs to run full nodes, essentially what that is, right? It creates the high amount of Nakamoto coefficient. So no matter what, if tomorrow half the internet gets shut down because someone presses a button for a nuclear bomb, well, you got these full nodes backing you up. If you have a staking network and you're dependent on half the nodes always to be online, if half the internet goes down, you're kind of hooped, right? So, these are the first principles we've been applying from Bitcoin back into an EVM model to serve utility. We got on the phone with the SEC, right? We demoed the compliance solutions we've been doing on the UTXO layer. And they basically had nothing bad to say, which is the best thing you can get from the SEC. But one of the things we've been thinking about, and there's two panels before they were talking about compliance as well, was how can we provide this, and FATFA is coming out with these guidelines now, how can we prevent, or actually do counterparty checks, but prevent stifling innovation with Web3? So we actually came up with a solution, and that's going to be part of the roll-up suite, is to provide compliant roll-ups as well. So we'll talk a little bit about that. And so where have we come from and where we're going? We've been around a long time, right? So since 2014, we've saw the big block debate. We saw and developed around Lightning networks. We've saw the challenges of CryptoKitties and EVM. And then in 2019, we saw the Starkware paper say ZK is the future, right? And it really is. This is going to unlock a lot of different use cases. We're talking generalized computing, AWS, GCP, DIDs, and blockchain scaling as well. It's also going to unlock privacy. And so it's very important that we take a hard look at ZK and how it applies to blockchain. Because this is going to, for investors, this is the theme that you're going to see for at least the next 5 years, is everything's going to be ZK. But how does that support our narrative economies of scale? How do we make it so that the more people that join, the cheaper it gets, right? Any Web 2 stack has the only way it provides scale, or has gotten there, is for economies of scale. And the only way to get adoption is to make amortized so that the more people use it, the cheaper it gets to run services, right? And there's a couple of things here. And they get kind of philosophical, right? But these are our principles as being kind of Bitcoin maxis in a way. We need to build sustainable civilization through improving quality of life. If we're not having a contract back with nature so that we use our resources more efficiently, we're kind of going backwards, right? If we're wasting our resources here just because we can, and then our future generations have to pay for it, at some point rubber hits the road and we are going to run out of resources. So we need to increase the quality of life of every single person in the world, so they make better informed decisions about how to use those resources in the world. They'll make better decisions if they're educated. And blockchains are a core part of that, because we're onboarding sovereign value. You can be your own bank, you can do DeFi, you can do anything in the world. You can get a job in different ways through DAOs, and that's how we're going to solve it. But it needs to be scalable. So economies of scale plays a really big part of this. And the last part, again, this is going to be very outlandish, but and Tesla is already thinking about this. But once we run out of resources here, what are we going to do? We're going to look elsewhere, right? Mars. We're already thinking about colonizing Mars. But how do you do financial transactions there? You're not going to be using Visa, MasterCard, right? It's going to be a blockchain-based system. But how do you actually do that? You have to remove the element of time. Because now we're dealing with distances of 10-minute delays between messages. You're not going to have an optimistic rollup, which has a 7-day delay period, and then multiple attack vectors because of a time. You have to remove the time element. And ZK replaces that. So you can have your own systems set up in ways where we're running the blockchains here, but there are systems there running in ZK and removing the element of time. It might sound outlandish, but I'm telling you, we've been researching this stuff for a long time, and this stuff is becoming a reality quicker than you think. John von Neumann has been touted as the father of modern computing, right? He created the modern architecture for computing, localized computing. But what I'm saying is we got to look at what he's doing, and there's a nice article I wrote on Syscoin.org. You can go check it out. We actually just did a refresh of the website, so go check it out. And what he's saying is, you need to separate into modular computing, hardware in terms of your disk, your memory, your CPU. Even the CPU is broken down into separate parts. There's the ALU and there's the CU. And the CU is like your blockchain, right? It's your control unit. The ALU is like your rollups. And the data availability, storing your transactions, that's your disk, that's your memory. But how do we go from there? Like, where are we going to go after that? If we look at what von Neumann did with localized computing and we apply that to blockchain, maybe we can get a global coordinated supercomputer, which is what the roadmap of Ethereum has always been. How do we get the local computer and expand globally? And by the way, in Princeton, when he met Alan Turing, they started talking and they're saying, these local computers are going to be great. AI is going to come out of this, right? Potentially, hopefully, AI will get created out of this. How can AI be formed if there's intermediaries in the middle? There's people. There's people in the middle saying you can do value transfer or you can do information transfer. No way, right? You need to remove that. It needs to be decentralized, and you need to have a coordinated global supercomputer that removes humans from the middle. AI can transfer into that system. So we need to think about the way von Neumann was doing computing to scale up blockchain. And that might mean different things. We don't know what that means, but let's get our head in that context if we want to scale up blockchain. So for us, Bitcoin is a great store of value. It's a Ponzi token economic system, right? It's it's designed to go up only. But what it does really good is a security and decentralization. Because it has Ponzi tokenomics, you have your deflationary periods every 4 years. It's going to get more and more and more and more secure. More work is going to get put in over time. Right, and that unmatched security needs to be tapped. We don't necessarily want to tap into the consensus, which means you have to use actual Bitcoin. It takes 10 minutes to transfer. It's slow, again, the tokenomics are not made for utility. We need to tie into the security, and we could do that. It's called merge mining. And Satoshi gave us that sort of recipe back in 2013, 14 on Bitcoin Talk, and not many people caught on. But we saw that and we built around that. And merge mining is a way to tie into the Bitcoin security directly behind it, and a way to provide subsidy to miners to mine other chains for free, carbon neutral, right? There's no extra cost. There's no extra carbon being spent. And you've taken existing systems like Bitcoin, which we know are not going away, and you've secured a system, an ancillary system that Bitcoin has no awareness of, except the miners know about it. So what happens when Bitcoin ends up, the subsidy goes to zero, right? They'll be depending on merge mining, right? That's the subsidy coming in. And Ethereum now, it's not a blockchain that you might think of like a traditional EVM, whatever. It's a data availability credit system. That's what Ethereum is today. As soon as they release dank sharding, proto-dank sharding, EIP 4844, the base layer is effectively a data availability credit system, a censorship resistance layer for rollups. And that's what we think of that as well. And so we're a mixture of both. We got the security of Bitcoin, we've got data availability built in, which not many other blockchains are doing, just Syscoin and Ethereum. There's the only two doing that. And we're building that sort of connection between Bitcoin and Ethereum in one tech stack. So privacy is a sticky point for regulators and all this stuff. So there's three things with privacy. There's privacy by option. There's Tornado Cash. We saw how that went, right? Like, it's an option, and you get caught if you're doing the wrong thing, and it's maybe not the best idea. There's privacy by design, Monero, Zcash. They're ground up made for privacy. And then the third one I came up with, and actually probably no one really knows about, is privacy by requirement. What does that mean? It means I want to create a system which requires privacy to scale up. Economies of scale. How do we do that? Well, if you think about the ZK roadmap, you have the ability to compute localized proofs. Meaning, if I want to do a transaction, I create a ZK proof myself, and no one in the world learns of what my intent is or what that transaction is. I send that out to the world, and it gets computed into a snark and put onto the base chain. This means that the world knows nothing about what anyone else is doing. It's completely parallelized. It's completely distributed. That's privacy by requirement. If you take the privacy away, you cannot get economies of scale. So I'm saying it's a requirement to get there. Now, there might be some fallbacks, but I think the pros outweigh the cons when we actually achieve economies of scale. We're unlocking all sorts of untold value. And that's what we're doing with Syscoin. We're creating these ZK layers. We're merge mining with Bitcoin. We're decentralizing the secondary layers so you can depend on them a little bit more. None of the rollups today are decentralized, but we are working on that to make them better. We have specific knowledge about UTXO. We're really experts on both tech stacks, and not many not many protocols are like that. We got the UTXO layer nailed down. We got the EVM layer nailed down. We're kind of thinking about how to apply these systems together. And Cardano's UTXO, Ethereum is EVM. We're talking to both. We're telling Cardano they need a data availability layer, or else they're not going anywhere. And Orbis is a ZK rollup on Cardano, and they can attest to that. But we're thinking about all these things, and we're helping other projects as well. We've got unique perspectives. We're probably one of the oldest chains, and we're going to be around for a long time as well. Polygon has a layer three sort of roadmap as well, and that's what we're doing. Some of the alpha. So we're launching Sys Labs, and I think I'm out of time here. So we're launching Sys Labs. We got $20+ million ecosystem fund we're just announcing today as well. So Sys Labs is effectively a bunch of different things we've been doing on the enterprise side, on the tokenomics. Multiple TGEs are going to come out of that, and we're going to funnel that into the Syscoin ecosystem, into the ecosystem funds, and build the ecosystem out. We got 18+ projects building already. We just announced it yesterday, and we're going to build that up into a unicorn of unicorn tech stacks. Thanks for listening, and enjoy your lunch.